So the basis of absolutely everything that we're going to do in organic chemistry is Lewis structures, and specifically the ability to generate Lewis structures for carbon-containing compounds. Having said that, you have largely already learned how to do Lewis structures in previous coursework, so I'm going to simply assume that you know how to generate one. So for example, if I asked you to generate the Lewis structure for HNO2, I would expect that you would have a system in place, an algorithm that you follow. And one of the better ways of approaching a problem like that would be to start by listing the total number of electrons each one of those atoms brings to the Lewis structure. And so basically you would have to know that a hydrogen atom brings a single electron and nitrogen brings 5 electrons, and then we have 2 oxygen atoms, so this would be 6 electrons times 2. And so that would be a total overall of 18 electrons for the Lewis structure. Then you have to choose which of the various atoms in your potential Lewis structure, HNO2, you'd like to be in the middle, the central atom, and you would choose most likely the most electropositive, the least electronegative atom, or alternatively another possible better way of thinking about it is the atom that can tolerate making the most bonds. So hydrogen likes to make 1 and only 1 bond, oxygen likes to make 2 bonds, and nitrogen likes to make 3 bonds, can tolerate making 4, but likes to make 3. And of course, nitrogen would be the least electronegative atom that's plausibly the central atom. Obviously, hydrogen is even less electronegative than nitrogen. So you start by putting the nitrogen in the middle, and then you're going to go ahead and you're going to bind the oxygens directly to the nitrogen. And now you have a choice. Where does this hydrogen go? Well, HNO2 is an acid, so if you happen to know that, nitrous acid, then you would have a tendency to put the hydrogen bound to one of the oxygens. A very common mistake here would be to put the hydrogen bound to the nitrogen. That's not the way this works. It does go this way. But then what you do is go ahead and fill out the remaining octets as best you could, starting with the atoms on the periphery. So in other words, we're going to go ahead and fill in all of these bonding electrons and make sure that each of the oxygen atoms ends up with 8 electrons. So we have 8 electrons over here, so that's 8 total. 8 more electrons over here, so that's 16 total. We have 18 electrons total that we're trying to use, which means they have to be right there because the hydrogen can't have them. All right, so now, are you done? Not quite, because now we need to consider formal charge. So the nitrogen brought 5 electrons to this bonding situation, and it has, at the moment, 4 electrons that belong to it. Mentally, what I like to do is just simply divide up each of these bonding pairs of electrons, these bonds, into 1 electron that belongs to the nitrogen and 1 that belongs to the oxygen. So in other words, I read this as nitrogen containing 4 electrons, even though it wants 5, and therefore it is short 1 electron, so it has a positive charge on it. Meanwhile, this oxygen brought 6 electrons originally, has 7 electrons that belong to it, 8 that it's sharing total, but 7 that belong to it, which means it has 1 more electron than it wants. This oxygen has 6 electrons that belong to it, 1 each from these bonding pairs. Again, the nitrogen gets 1, the oxygen gets 1, the hydrogen gets 1, the oxygen gets 1. 2 lone pairs. So this oxygen has 6 electrons. It brought 6 electrons. This oxygen is no formal charge, neutral. All right, so are we done? No, there's too much formal charge. So now we're going to do something that will become quite familiar to you in the future. We're going to draw a resonance structure, a better Lewis structure, in fact. And so what we're going to do is push these electrons from this oxygen lone pair to make a double bond to that nitrogen. Therefore, the better way of writing this out is going to look something like this. So now it's time to consider the charges once again. And again, what I like to do is sort of mentally divide up any bonding pair of electrons into their separate components. The oxygen gets 1, the nitrogen gets 1, the oxygen gets 1, the hydrogen gets 1. This oxygen gets 2, 1 from each bond, but the nitrogen gets 2, 1 from each bond. That's the way I do it mentally. So each one of those shared pairs gives 1 to each atom. All right, so how many electrons does oxygen bring? It brings 6. It has 1, 2, 3, 4, 5, 6. Therefore, this oxygen is happy, neutral, no charge. This oxygen likewise brought 6, has 6. They are both neutral and content. The nitrogen has 5 electrons that belong to it, which is correct as well, and that's how you do Lewis structures in general. Now, this is a relatively complicated Lewis structure in that it has the resonance and the need to consider formal charges, which is why I chose it. But if you struggle at all with generating Lewis structures of this type and evaluating whether this is done or whether you need to go further and so on and so forth, then I would invite you to go back to your previous coursework and reevaluate your Lewis structure skills. This is an absolutely foundational skill for organic chemistry. You absolutely need to have it. In fact, you cannot do anything else in organic chemistry unless this foundation is rock solid. So make sure you have this one.